In this video, I introduce a maximum margin principle for inverse reinforcement learning. Agent in imitation learning finds a policy and then uses the policy to imitate expert behavior. Maximum margin principle is used to frame inverse reinforcement learning into a quadratic programming problem. Suppose the input of a maximum margin principle is a set of demonstrations. Here, X is the state space, A is the action space, P is the transition probability, YI is the export trajectory. Here we use the state action frequency count mu at state action pair to express the export trajectory YI. Our goal is to learn the policy from export trajectory, our agent and learn the policy to generate a trajectory close to the export trajectory YI. Also, we use this state action frequency constant to define the policy. Here, F is a feature matrix. We use this feature matrix to map the state action frequency count to the expected feature count, and further map this expected feature count to a real world. Suppose a linear mapping is defined real world function, and then the optimal policy is estimated from the real world function. That means we search for policy, make this real world maximum, find the optimal policy. This optimal policy over this real world functions is close to the export policy mu I. And then we define the loss function to evaluate the learned policy through this loss vector L. So our goal is to find a policy that generate a trajectory significantly better than other trajectory by a margin. This margin is proportional to the loss. Now let's see how can we use the maximum margin principle to frame the inverse reinforcement learning to a quadratic programming problem. Suppose this features and this loss function is linear, so we can get this quadratic programming formulation. That means we need to find the weight vector W to satisfy this constraint. Namely, this expected real world and the export policy. And this expected real world and the learned policy. We need, this value is larger than this value by a margin that is loss. On the one hand, we find this W and make let this term larger than this term by this margin. On the other hand, we use this W to calculate this optimal policy, and this policy agent generates this trajectory. And then we compare this trajectory with the export trajectory. Upon convergence, then this margin is minimal. That means the maximum policy is close to the export policy. And then the agent uses this policy to imitate the export behavior. For more details, please check with this reference. Thank you. Bye.